Welcome to the MOOCs course Mechanical Unit Operations. In the previous lecture of this course, we have seen principles of cake filtration under the constant pressure filtration as well as the constant filtration rate process conditions as well. So, within the constant pressure filtration case, we have seen what are the governing equations for the batch process as well as the continuous process. And for the continuous process, continuous flow rate or continuous volumetric flow rate process, we have seen corresponding equations, governing equations as well. So, now in this particular lecture, we are going to have a kind of a few example problems both for batch and continuous pressure filtration processes, and then we discuss some details about centrifugal filtration processes, followed by problems on centrifugal filtration processes. So, let us take example number 1. So, data for the laboratory filtration of calcium carbonate slurry is in water at 298.3 Kelvin are reported as follows in a below table at constant pressure drop of 338 kilonewton per meter square. The filter area of the single plate and frame filter press was 0.0439 meter square, and then slurry concentration was 23.47 kg per meter cube. The viscosity at this temperature is 8.937 into 10 power minus 4 Pascal second. The table data is given in the next slide. So, calculate the specific cake resistance and filter medium resistance from the experimental data given below in the next slide. So, the first problem is about how to calculate the filter medium resistance as well as the specific cake resistance under constant pressure filtration conditions. The experimental data time versus filtrate volume collected is given here. So, filtrate volume is now here multiplied by 10 power 3. So, that means 0.493, that means 0.498 into 10 power minus 3 meter cube of filtrate volume would be collected by time 4.4 seconds. So, like that all the filtrate volume at different time levels are given here, at different time intervals are given here. So, this information we have to use. Basically, T versus V information is given. So, we have the equation T by V is equals to Kc by 2 V plus 1 by Q naught, and then T by V versus V if you plot, you will get a kind of a straight line with slope Kc by 2. Using this Kc value, you can get the specific cake resistance, and then intercept of this line would be 1 by Q naught, and then using this 1 by Q naught intercept value, you can calculate the filter medium resistance Rm. That is what the process that we are going to follow in order to get alpha and Rm values as required by the problem. So, we know that T by V is equals to Kc by 2V plus 1 by Q naught, and then Kc is mu alpha C by A square delta P, and 1 by Q naught is mu Rm by A delta P. So, in this equation everything is known. So, plot T by V versus V, so that you get a linear plot, and from slope alpha can be calculated and from intercept Rm can be calculated. Right. So, let us rearrange the data T by V versus V, and then if you plot that data you will get a kind of a straight line like this. So, this T by V multiplied by 10 power minus 3 versus V into 10 power 3 is there. So, whatever the slope that you will get, that slope has to be multiplied by 10 power 6, and then whatever the intercept is there, that should be multiplied by 10 power 3 because of this 10 power minus 3 here and 10 power 3 here. Right. So, this T by V versus V, the plot is like a linear plot where in the form of y is equals to mx plus c, slope is 2.885 and then intercept is 6.7838. So, from here slope Kc by 2 is equals to 2.885 and that should be multiplied by 10 power 6, right. Then Kc is nothing but 5.77 into 10 power 6 second per meter power 6. But Kc we know it is mu alpha C by A square delta P. So, in this expression except alpha everything is known. So, alpha you can write it as Kc A square delta P by mu C. So, Kc just now we found it as 5.77 into 10 power 6, A is nothing but 0.0439 and delta P is nothing but 3.38 into 10 power 5 pascals divided by mu is 8.937 into 10 power minus 4 pascal second, and then C is given as 23.47. When you calculate simplify this expression, you will get alpha as 1.7919 into 10 power 11 meter per kg. Similarly, intercept 1 by q naught is 6.7838, but that should be multiplied by 10 power 3. When you multiply by 10 power 3, you will get 6783.8, and then that 1 by q naught is nothing but mu Rm by A delta P, and then from here you can get Rm as 1 by q naught A delta P by mu. Substitute all the values, simplify. So, Rm value you will get 1.1263 into 10 power 11 meter inverse, right. So, this is about the first problem. Now, example 2, the same slurry as in example problem 1 is to be filtered in a plate and frame filter press. This is one type of filtration equipment we are going to see in the next lecture, having 20 frames and 0.873 meter square area per frame. The same pressure will be used in constant pressure filtration as in example number 1. Then assuming the same filter cake properties and filter cloth, the filter medium properties, calculate the time to recover 3.37 meter cube of filtrate. Basically, all the conditions are exactly same as in the previous problem, except the area, filtration area has been changed. Filtration area earlier it was 0.0439 meter square. So, now here we are using plate and frame with 20 frames, each frame is having 0.873 meter square area. So, the overall filter area would be 0.873 into 20. Right. Further, it mentioned that everything is same as in the example number 1. So, alpha and Rm etc. will also be same as in example number 1, but then what is changed? Change is area. If area is changing, according to new area, what is the Kc slope, what is the intercept 1 by q naught, that you have to modify, and then from there you further make use of the same equation to get the time required to get 3.37 meter cube of filtrate. So, that is, in this problem everything is same as in example 1 except the area of filtration is changing. Since area of filtration has changed, the time required to collect a specific volume of filtrate will also change. Since cake resistance and filter medium resistance are same as in example 1, values of Kc and 1 by q naught should be corrected according to new area, because these are functions of filtration area. How they are functions of filtration area, that we see. Filtration area of this problem is A nu, if you designate as the kind of nu, is 0.873 per press, and then there are 20 such presses. So, multiply by 20 you get 17.46 meter square, right. Then Kc we have mu alpha c by a square delta p. So, that means Kc is inversely proportional to a square. So, Kc for new area, if you wanted to calculate and you designate it as Kc new. So, then we have Kc new by Kc old. Kc old stands for now for the previous problem example 1. So, Kc new by Kc old should be a square old by a square new, right. A square old in the previous example, what is the area? 0.0439 square of it divided by new area for this problem is 17.46 and square of it. When you do it, you will get 6.3218 into 10 power minus 6. If you multiply it by Kc of example 1, previous that old example Kc, that is 5.77 into 10 power 6, then you will get new Kc as 36.4786 second per meter power 6. So much it has decreased. In the previous case, it was order of 10 power 6, now it is order of 10 power 2 only. Similarly, 1 by q naught in the Previous case 6783.8, that is nothing but mu Rm by A delta P. So, what we understand from here, 1 by Q naught is inversely proportional to filtration area. So, that means if you wanted to calculate 1 by Q naught for as per the new filtration area, 1 by Q naught new should be 6783.8, that is 1 by Q naught of previous example problem. This is 1 by Q naught old, that is example 1 value, multiplied by old area, the previous problem area 0.0439 divided by this problem filtration area 17.46, right. Then you will get 17.0566 second per meter cube as a kind of a new 1 by Q naught or 1 by Q naught for this case. It also substantially changing, right. Previous case it was order of 10 power 3 to 4, now here it is order of 10 power 2 only, 10 power 1 only. Okay. So, accordingly the time would also be very much different to collect required volume. So, now we have this equation T by V is equals to Kc by 2 V plus 1 by Q naught. So, now here Kc by 2 and then 1 by Q naught, they should be used for a kind of new conditions, that is new filtration area, and then V is given. To collect certain value of V, how much time is required, that you can calculate now from this equation. So, T is equals to whatever this new Kc value is 36.4786 by 2 and then V 3.37 meter cube volume if you wanted to collect. So, whatever the left hand side V is there, we are taking to the right hand side. So, there will be V square for first term and then second term it will be multiplied by V. So, 1 by Q naught for new case is 17.0566 multiplied by V is 3.37. So, that comes out to be 264.6 seconds, which is closely 4.41 minutes. Okay. Now, you can compare both the cases. In the previous case, in the example, in order to get 3.37 meter cube of volume of filtrate, you have to give only less time, whereas here it has to be large time, 4.41 minutes. Okay. Likewise, these comparisons one can make. So, now example 3. You take a homogeneous sludge forming a uniform incompressible cake and is filtered through a batch leaf filter at delta P 40 psi, okay, and then forming a 3 by 4 inch cake in 1 hour with a filtrate volume of 1500 gallons. So, pressure drop is given, filtrate volume is given, cake thickness is also given 3 by 4 inches, and then filtration time is also given as 1 hour. Further, 3 minutes are required to drain the liquor from the filter and then 2 minutes are required to fill the filter with water. This is about washing process. Okay. Washing is also included. Washing proceeds exactly as in the kind of filtration process using 300 gallons of water. Okay. So, opening, dumping and closing of this filtration process takes approximately 6 minutes, right. So, assuming the filtrate to have the same properties as wash water and neglect the resistance of filter cloth and flow lines, that is Rm is negligible. What is the total cycle time and how many gallons of filtrate are produced on average per 24 hours? That is the question. Total cycle time. This total cycle time is total time for the filtration, total time for the washing, and then total time that is there for individually draining the liquor or filling water, etc., those kind of things. So, all the time should be added together to get the total cycle time. Filtration time is also given 1 hour, but washing time is not given. So, we have to find out the washing time. So, once you find out the washing time, add that time to all these filtration time of 1 hour and then draining of liquor 3 minutes and then filling the filter with water 2 minutes, and then closing, dumping, opening, etc. 6 minutes. If you add together all the times, you will get the cycle time. So, in order to know the cycle time, you need to know wash time also, that is what you need to calculate. But washing proceeds exactly same as the filtration, that is also given. So, whatever the constant pressure filtration process equations are there, T by V is equals to Kc by 2V plus 1 by Q naught, those equations we can use here also. Okay, because washing proceeds exactly same as the kind of filtration, and then filtration is at constant pressure of 40 psi. Further, in this equation most of the things are given in a kind of FPS units. So, what we will be doing, we will be solving this problem in FPS units. So, delta P is 40 psi, that has to be in kind of LB mass per feet square. So, sorry, that has to be LB force per feet square. So, inches are there, 40 per square inch. So, 1 inch is 1 feet is nothing but 12 inches. So, feet square should be 144. So, 40 has to be multiplied by 144. So, then you will get delta P as 5760 LB per feet square. This is simple conversion from PSI to LB per feet square. Okay. Volume of filtrate is given as 1500 gallons, but 1 feet cube is equals to 7.481 gallons, especially US gallons. Actually, these conversions, gallon conversions are different for UK and then US. So, let us take US gallons conversion. So, according to US gallon conversions, 1 feet cube is nothing but 7.481. So, when you do the conversion, you will get V as 200.508 feet cube. Cycle time is summation of time for filtration process and washing of cake along with all other time of draining, filling kind of thing, and then dumping, closing kind of time, whatever all the times are there, all those times are included or added together to get the cycle time. So, filtration process, draining is 3 minutes, and then filling is 2 minutes. Filtering is done for 1 hour, so 60 minutes. So, 65 minutes, and then opening, dumping and closing is 6 minutes. So, 71 minutes is taking per filtration process, 71 minutes for the filtration process. But we should also include the washing time also. In the washing, wash water filling is required, so that is 2 minutes given. Wash water drain, so draining time is 3 minutes, because whatever the filtration is there, the same way washing is also taking place. So, for the filtration, whatever the draining or filling times are there, same time should be taken for the washing as well. So, 71 plus 5, 76 minutes till now all this time, right. So, and wash time, that is not given, so we have to find out. So, total cycle time is going to be 76 minutes plus wash time. If you find the wash time, first part of the question would be done. Okay. How to do? So, we have this equation delta P is equals to mu u MC alpha by A plus Rm. So, now we are using FPS units. Since FPS units are using, so then this wherever the forces are involved, the conversion GC has to come into the picture like this. So, GC is having 32.17 this feet per second square units. Okay. So, it is similar like conversion for acceleration due to the gravity kind of things. Okay. So, but as given in the problem, Rm is negligible. So, you can strike out this part, Rm is negligible, it is given in the problem. So, this equation further now you can write it mu u by Gc MC alpha by A. So, MC you can write V multiplied by C, and then u you know it as dV by dt divided by the filter area A. Okay. So, now if you substitute this thing here, you will get delta P is this one, and then you rearrange this equation such a way that dt by dv is one side and all other terms are other side. Okay. So, this equation, by integrating above equation, what you get, t is equals to, you will get mu alpha c by a square delta p gc v square by 2 plus c1. So, but at t is equals to 0, v is equals to 0, because there is no filtrate collected at t is equals to 0. So, then constant c1 should also be 0. So, then what we have, this t is equals to this mu alpha c by a square delta p gc v square by 2, right. So, if right hand side of this equation, if everything is known, then we can use this equation straightforward to get the wash time. But here alpha is not known, and then mu is also not given, c is also not given, a is also not given. So, what we have to do? We have to do some mathematical steps in order to avoid requirement of these things. So, for the filtrate, what it is given, in order to get 1500 gallons. So, before that one, what we do, the same equation we rearrange like v square one side and then all other times other side, and then right hand side terms delta p t which are known. So, these things we keep as it is, and then rest all other terms a square delta p t terms we retain as it is, and rest all other terms we can write it as 1 by c2, that is v square is equals to a square delta p t by c2, where 1 by c2 is nothing but 2 gc by mu alpha c, which is not known, right. Mu is not known, alpha is not known, c is not known. Okay. So, that we are taking as some constant 1 by c2. Now, but for the filtrate, 1 hour filtrate 1500 gallons, that is given, that is given. So, we for the filtrate filtration process is given 1500 gallons. When we converted it to the feet cube, it has come as 200.508 feet cube. So, v square, the square of this value is equals to a square, a value we do not know, c2 we do not know, delta p it is given 40 psi, in lb force per feet square it is 5760, and then filtration time t is also given 1 hour. So, that we write as 60 minutes, because cycle time we are writing in in minutes. So, that is the reason. So, from here a square by c2, how much you will get? 0.1163. So, unknown whatever the things are there, a square by c2, that you have calculated from filtration information. In 1 hour filtration you get 1500 gallon, that is given, right. Now, this value you can make use for wash liquid, right. So, but this equation dt by dv is equals to the same equation, previous equation. When you remove the Rm value, you rearrange this equation like this. So, then you will get dv by dt is equals to this equation, and this 2 gc by mu alpha c is nothing but 1 by c2. So, when you write dv by dt is equals to a square by c2 delta p by 2v. A square by c2 you just calculated as 0.1163, and then delta p is 5760 lb per feet square, and then v is nothing but 200.508. When you substitute all these things, volumetric flow rate you will get 1.6705 feet cube per minute. This is again for the filtration. This is again for the filtration, because we have used volume of filtrate collected here. So, filtration is there, and whatever the volumetric flow rate of filtrate is there, that is 1.6705 feet cube per minute. If you convert it into the gallons, because it is given in gallons, right. So, it comes out to be 12.5 gallons per minute, because in 1 hour 1500 gallons you are getting that, then per minute how much you will get? 12.5 gallons per minute you get anyway, that is same thing by calculation. Okay. So, this information we will be using in order to get the wash time. So, this dV by dt value equals the rate of washing because both filtration and washing proceed same way with properties as given in problem 1. So, thus washing time should be volume of wash water divided by the volumetric flow rate of wash liquid. So, time for washing is 300 gallons of water is used for washing. So, 300 gallons divided by 7.481 if you do, that will be feet cubes of water required, dividing by volumetric flow rate of wash liquid is nothing but volumetric flow rate of the filtrate, because both of them are proceeding same way. So, volumetric flow rate of filtrate we already calculated as 1.6705 feet cube per minute. So, that comes out to be 24.0057. So, that is approximately 24 minutes. That means total cycle time is nothing but 76 plus 24 is equals to 100 minutes. Now, average filtrate per 24 hour is required, the second part question. So, filtrate volume is 200.508 feet cube per minute, and then cycle time is now 100 minutes, right. So, but we need in per 24 hours. So, if you multiply by 60, that would be per hour, and then further multiplied by 24, that would be per 24 hours. This is the second part of the question. So, that comes out to be 2888.006 feet cube per 24 hours, and then if you convert this one into the gallons, it will be 21605 gallons per 24 hours. This is the average filtrate that you get per 24 hours of process time, filtration time. Right. Now, we go to the another example problem. The following relation between alpha and delta P for superlight CaCO3 has been determined to be: alpha is equals to 8.8 into 10 power 10 multiplied by 1 plus 3.36 into 10 power minus 4 delta P power 0.86. So, now here cake is compressible cake, because that alpha as function of delta P is given. Okay. Delta P is in pounds force per square foot. So, in this equation, if you wanted to get alpha value for a given delta P value, this delta P has to be lbf per feet square, that units has to be used. Okay. This relation is followed over a pressure range of 0 to 1000 lb force per inch square. So, but this range is given in inch square, so you have to convert in feet square. Slurry of this material giving 3 lb of cake solid per cubic foot of filtrate is to be filtered at a constant pressure drop of 70 lb force per inch square and at a temperature of 70 degrees Fahrenheit. Experiments on the sludge and in filter cloth to be used gave a value of Rm is equals to 1.2 into 10 power 10 feet inverse. Rm value is also given. A pressure filter of tank type is to be used. The viscosity of the filtrate that you collect is 6.6 into 10 power minus 4 lb per feet second. Now, the question is, how many square feet of filter surface are needed to give 1400 gallons of filtrate in an hour of filtration? So, this part of the question is a kind of measuring the filtration area. Okay. So, again we will be solving in FPS units. Alpha is given this expression, C is also given 3 lbs of cake deposited on filter medium per feet cube of filtrate, that is given directly. Delta P is given in lb force per inch square. So, that you have to convert into the lb force per feet square, because here in this expression alpha, delta P has to be lb force per feet square as per problem statement. So, delta P is 10080 lb force per feet square. So, that if you substitute here in this alpha expression, you will get specific cake resistance at this pressure drop. Rm is given this value right. So, in the equation delta P, when you substitute alpha, you will get 1.7 into 10 power 11 feet per LB. Okay. Volume of filtrate collected is also given 1400 gallons. So, if you divide it by 7.481, it will be converted into the feet cube. So, 187.2 feet cube. Viscosity is also given this value, right. So, now we have to use this same equation here, because in this equation Kc, Q naught, if you write in terms of alpha and Rm everything. So, everything is known except that A value, the area filtration area, that you can calculate here. So, before that what you do, you expand it, or you straightforward find out what is Kc, what is 1 by Q naught, because everything is known. Mu is given, alpha is given, C is given, right, delta P is given, Gc is 32.174. So, in Kc except A square everything is known. When you substitute, you will get Kc is equals to 1037.9 by A square. Similarly, 1 by Q naught is mu Rm by A delta P Gc. Here also except A everything is known. Substitute all the values, simplify. So, you will get 1 by Q naught is equals to 24.42 by A. So, this Kc and 1 by Q naught, if you substitute in this equation, then you will get required area for this filtration, which provides 1400 gallons per an hour. So, it is given per an hour. So, T is given, that is 60 minutes. So, 3600 seconds is equals to that, whatever the V is there in this equation, that also we are taking to the right hand side. So, Kc is nothing but 1037.9 by A square, and then 2 is as it is, and then we take to the right hand side. So, V square. So, V is also given, 1400 gallons is nothing but 187.2 feet cube. So, 187.2 square plus 1 by Q naught is nothing but 24.42 by A, and then this should be multiplied by V, that is 187.2. When you simplify this equation further, you get this quadratic equation. When you solve this equation, you get two roots, and then reliable root is 71.713 feet square. This is the filtration area required. Okay. Now, we take another example problem, but followed up of the example number 4. So, a continuous pressure filter is to yield 1400 gallons per hour of filtrate from the slurry described in previous example 4. So, the properties alpha, Rm, viscosity, everything has to be taken same as in a kind of a previous example number 4. The pressure drop is limited to a maximum limit of 50 lb force per inch square. In the previous problem, the pressure drop was 70 lb force per inch square, but here in this problem it is restricted up to 50 lb force per inch square. How much filter area must be used provided if the cycle time is 3 minutes and drum submergence is 50%? Right, the previous one that we have done for a kind of a batch process, okay, constant pressure but batch process. This problem is the same slurry, same properties of cake resistance, Rm, etc., viscosity of filtrate, etc., but this problem is constant pressure but continuous filtration, not the batch filtration. So, here we have to use the equations corresponding to the continuous filtration. Okay. So, alpha is given this expression in the previous problem. So, same we have to use. C is also this value we given in the previous problem. Delta P now in this problem is 70 lb force per inch square, whereas in the previous problem it was 70 lb force per inch square. Now, it is in this problem it is 50 lb force per inch square. When you convert into lb force per feet square, because here in alpha definition delta P has to be lb force per feet square. So, when you convert into convert inches into feet, then do the simplification, you get 7200 lb force per feet square as a kind of pressure drop. Rm is given 1.2 into 10 power 10 feet inverse So, in this equation here, now this 7200, if you substitute here, you will get alpha as 1.49 into 10 power 11 feet per lb. Okay. So, this is the change compared to the previous problem, because the pressure has changed. Pressure has decreased from 70 lb per inch square to 50 lb per inch square. So, alpha has also slightly decreased. So, V is given as a kind of a 1400 gallons, and then this gallons, if you convert into the feet cube, it comes out to be 187.2 feet cube, same as the previous problem, but per hour it is given 1400 gallons per hour. So, that is volumetric flow rate V by T is given as 187.2, T is 1 hour. So, that is 3600 seconds. So, we have 0.052 feet cube per second, and m dot c is nothing but c into V by T, that we know. So, c is given as 3 in the previous problem, V by T here in this problem is 0.052. So, m dot c you will get 0.156 lb per second. Viscosity is given, and then as I mentioned, in the continuous process continuous filtration process, the area of filtration is not the entire area of the filter medium, but only the fraction of area that is submerged in the slurry, that area should only be taken as a kind of filtration area. So, here 50% of the filter medium is submerged in the slurry. So, F is 0.5. So, and then cycle time is given as 3 minutes. So, N should be coming out as 1 by 3 multiplied by 60. So, that is 0.00556 revolution per second, right. Then we have this equation for continuous constant pressure, but continuous filtration process. We have this equation. In this equation now, AT is known, because the fraction of area, that is AT is to be calculated, okay, how much is the filtration area, right. This RM is known, N we just calculated here, this one, delta P is given, alpha is known, C is known, F is known 0.5, N is known, mu is known, everything is known in this equation. RM is known, everything is known. So, when you substitute all these things, including this MC is also known. So, only thing unknown is AT. So, that AT you will get it as, when you substitute all these values and simplify, you will get that value as 26.7 feet square. Okay. Now, we go to the case of centrifugal filtration. What happens in general centrifugation, separation by centrifugal forces, there is a kind of ball, and then this ball is rotated with a kind of high speed, or with a kind of certain speed in general, right. When this rotation takes place, a kind of centrifugation forces will also develop. Let us say initially slurry level is something like this before rotating this ball. So, when you start rotating the ball, what happens? The interface will slightly move like this, depending on the speeds, right. If you rotate at very high speed, so then interface may be like this. So, all the material is here only. So, if you rotate at very high speed, so then there may be kind of cases like this, the most of the material are something like this here. Okay. So, now these cases, when the centrifugation takes place, whatever the heavier material is there, that is now here in this case slurries, in the slurries particles are the kind of heavier materials. Particles would be gradually deposited on this surface of the ball, like this, either side. Okay. The particles would be forming a kind of cake along on this surface, ball surface, like this, around the ball surface, okay. And there will be a kind of a clear liquid next to it, like this. So, here we have a kind of cake, you have a kind of liquid, okay. So, now this, it is, let us say, rotating at omega speed, something like that. So, now we have a kind of, we take a kind of case where such kind of clear separation of cake and then liquid is possible as a kind of ideal case like this, and do the analysis. So, what is the pressure drop under this condition? That pressure drop is related to the omega and then density of the ball, etc. Okay. Omega and density of the liquid, whatever the filtrate liquid is there, that density, etc. It depends on that one. Also it depends on the inner radius of the ball, this is R2, and then the clear interface of the liquid, whatever is there, that is a kind of R1. The interface between the cake and then clear liquid is known as the Ri. So, that means if you know the ball radius and then if you know the thickness of the cake, you can know what is Ri. R2 minus thickness of the cake, if you do, you will get Ri. Okay. So, delta P is in general rho omega square multiplied by R2 square minus R1 square. This is anyway we are going to derive in subsequent lectures. For the time being we'll be taking like this. This is what happens in centrifugal filtration. So, whatever the rotational speed is there, that can be related to the delta P. So, under such conditions, what is the Q? This is a kind of continuous process. Continuously cake is being taken out, continuously liquid is taken out. So, what is the volumetric flow rate in meter cube per second? That you can principles that you can develop here, or you can develop the equation, those you can use for calculation for a given system. Okay. Right. So, basic constant pressure filtration theory, whatever is there, that can be modified to apply centrifugal filtration here as well. So, this theory applies after the cake has been deposited and during the flow of clean filtrate or fresh liquid through the cake. It is a kind of continuous process when there is a whatever the equation that we are going to develop. So, it is valid for the case where already there is a certain amount of cake is already deposited and then the clear filtrate or fresh liquid is passing through the cake. So, there are several assumptions here because so many things are happening in centrifugal filtration. So, what are those assumptions? Effects of gravity and of changes in kinetic energy of liquid are neglected compared to the centrifugal forces. These quantities, gravitational force and then kinetic energy, are very small. That is what it mean by. And then pressure drop from centrifugal action equals the drag of the liquid flowing through the cake, same as a kind of packed bed case. Cake is completely filled with liquid. So, interstitial space between the particles within the cake are not free, they are already always occupied by liquid, and then flow of liquid is laminar, and then resistance of the filter medium is constant, it is not changing. Cake is nearly incompressible, that is average specific cake resistance should be used as a kind of constant value. Okay. These are the some assumptions. Then centrifugal filters. So, let us say this is the axis of the ball, the only one side we are drawing it, the same side, same is other side also. Under the idealized conditions, when the cake is the solid particles are depositing along the ball surface, inner surface of the ball as a kind of cake, they are deposited, all the particles are deposited along the inner surface of the ball, and then they are forming kind of cake, and then there is a clear liquid adjacent to it. Okay. So, these interfaces are not straight ones like drawn here. In general, we may be having a kind of interfaces, something like this, right. However, we take for this is for the cake and this, let us say, for the liquid. So, we take this is a kind of almost a kind of straight one, something like this. For simplification, we take this is a kind, this interface of liquid as well as the cake that has formed is having a kind of a uniform thickness along the vertical dimension of the ball, that is along the B. At the bottom whatever the thickness is there, the same thickness is there at the top, which is in general not true, right. So, further nomenclature we can take here. So, R1 is the radius of inner surface of the liquid, and then Ri is the radius of inner surface of the cake, and then R2 is the inner radius the inside radius of a basket, and then B is nothing but the height of the basket, and then omega is the angular velocity in radians per second at which the ball is rotating, and then Q is the volumetric flow rate of liquid that is being continuously taken out, rho is the density of the liquid, right. So, now whatever the constant pressure filtration equations are there, they can be same, can be used here with a kind of a few modifications. What are those few modifications we are going to see now. For a thin cake in large diameter centrifuge, the area A for flow does not change much with radius, nearly true, because if the ball that if you take here, if this area, the cake is very thinner, this cake is very thinner, then this area is going to be very large, A is going to be very large. So, because of that one, this area for flow does not change much with radius of the cake that has been formed, because the cake is a kind of thin cake now. Thus, the linear velocity of liquid can be written as u is equals to dV by dt by A. So, dV by dt we can write it as Q by A, and now we have this equation number 6 developed in the previous lecture. Delta P is equals to delta Pc plus delta Pm, that is equals to mu u mc alpha by A plus Rm. Now, in this equation substitute u is equals to Q by A, then you have this equation, right. So, but under the centrifugal force, what is the pressure drop here? The pressure drop is, as I mentioned, rho omega square R2 square minus R1 square by 2. This we are going to derive when we discuss the centrifugal separation process in later part of the course. Okay. For the time being, let us take this equation as it is. Okay. So, now this delta P in equation 31 and this delta P in equation 32, if we equate, then you get an expression for Q, that is Q is equals to R omega square R2 square minus R1 square divided by 2 mu alpha mc by A square plus Rm by A. Now, when change in A with radius is too large to be neglected, then this A square is written as AL bar and then AA bar to match better with experimental observations in general, where A2 is the area of the filter medium inside area of the centrifugal basket, that is whatever the 2 pi b R2 is there, that is A2 here, because this filter medium resistance, this A2 is nothing but area of filter medium, that is inside area of centrifugal centrifuge basket, that is 2 pi b R2, and then AA bar is nothing but arithmetic mean of cake area, that is pi b Ri plus R2, because cake is between Ri to R2 only that part is the cake. So, pi b multiplied by Ri plus R2 would be giving the arithmetic mean of cake area. It is arithmetic mean. Similarly, logarithmic mean of cake area can be taken as 2 pi b R2 minus Ri divided by ln R2 by Ri, right. So, this equation 34 whatever developed in terms of AL bar, AA bar and A2 applies to cake of definite mass and is not an integrated equation over the entire filtration starting with an empty centrifugal. It is not like, as I mentioned at the beginning of the principles of centrifugal filtration process, what we have taken, these equations are valid for the case where already cake has been deposited on the ball surface and then liquid is continuously flowing through and then being separated as a kind of fresh liquid as a clear filtrate, right. So, this is for the such conditions it is valid, but it is not a kind of overall integrated equations kind of thing as we have seen in the pressure filtration processes. Alpha in these equations is somewhat greater than that we found in a pressure or vacuum filter under comparable conditions. For compressible cakes, alpha increases with applied centrifugal force. However, in this theory, whatever the equations that we develop, there we assume that alpha is independent of delta P, and then a average delta P should be taken as a kind of constant value for that alpha, though it increases with increasing the centrifugal forces. So, now we take an example problem based on the centrifugal filtration process. Here a batch centrifugal filter having a ball diameter of 750 mm, that is R2 by that is 2 R2 is 750 mm and height B is 450 mm is used to filter a suspension having following properties. So, it is a liquid water at temperature 25 degrees centigrade has been used. Concentration of solid in feed is 60 gram per liter. Porosity of cake is 0.435. Density of dry solid in cake is 200 kg per meter cube. Final thickness of cake is 150 mm. Speed of centrifuge is 2000 rpm. Cake resistance alpha is 9.5 into 10 power 10 feet per lb. And then filter medium resistance Rm is 2.6 into 10 power 10 feet inverse. Then final cake is washed with water under such condition that the radius of inner surface of the liquid is 200 mm. So, that is R1 is 200 mm, that is also given. Then assuming that the rate of flow of wash water equals the final rate of flow of filtrate, calculate the rate of washing in meter cube per hour. So, that means straightforward that filtration and then washing occurring in the same way, exactly the same way. So, whatever the filtrate volumetric flow rate Q that you find out, the same thing would be the wash liquid volumetric flow rate in meter cube per time. So, per it is required in per hour. So, you get meter cube per second, that you have to convert into the meter cube per hour. So, for water at 25 degrees centigrade, rho and mu we can find these values from any standard textbooks. Omega is required, but n is given. So, 2000 rpm is given. So, 2 pi n by 60 if you do, that will get omega in radians per second. Alpha is given in foot per lb, so that you have to convert in mass per kg. Similarly, Rm is given in foot inverse if you have to convert in meter inverse units. B is given 450 mm, that is 0.45 mm. R2 is given 750 by 2, that is 375 mm or 0.375 meters. R1, that is inner surface of the liquid radius is 200 mm, that is given. So, that is 0.2 meters is R1. Cake thickness is given as 150 mm, so that is 0.15 mm. So, Ri you can calculate by subtracting this cake thickness from R2. So, Ri is equals to R2 minus cake thickness, thus 0.375 minus 0.15 is equals to 0.225 meters. So, now everything is known here except the MC. MC is nothing but let us say the volume of the cake that you have to find out, then you multiply it by the density of the particles, then you will get it. So, cake is like between R2 and then Ri, right. R2 and Ri, that distance only cake is there. So, within that only solid particles are there. So, pi b into R2 square minus Ri square multiplied by 1 minus epsilon, if you do, you will get volume of the particles within the cake, because that entire cake is not full of particles, there are interstitial spaces filled with the liquid. So, that interstitial spaces is epsilon, 1 minus epsilon is the fraction of the particles. So, pi b into R2 square minus Ri square multiplied by 1 minus epsilon. If you do, you will get the volume of particles within the cake, and then if you multiply that one by the density of the particles, you will get the mass of the particles within the cake, that you will get 143.8 kg, because here everything is known. Everything is known in this equation. So, substitute all these numbers, you will get 143.8 kgs. Then A bar is nothing but pi b into Ri plus R2, arithmetic mean of cake area. So, that you can calculate here. Similarly, logarithmic mean of cake area also you can calculate by this 2 pi b R2 minus Ri by ln R2 by Ri. So, you will get 0.83 meter square, and then A2 is the filter medium, that ball area, that is 2 pi b R2. So, that comes out to be 1.06 meter square. So, everything is known now in this equation of Q. In this equation of Q, everything is known. Rho is given, water we got the properties, omega we got, R2, R1 is known, mu is known, alpha is known, Rm is known, MC calculated, Al bar, A bar, A2 you have already calculated. You substitute all these numbers here, so then you will get Q as 1.67 into 10 power minus 5 meter cube per second. That if you wanted to make it in a kind of hours, so what you have to do, you have to multiply it by 3600. When you do it, you will get 0.601 meter cube per hour. This is how we can solve problems related to the cake filtration. Okay. So, what we have done in this class, we have solved several problems based on the cake filtration by pressure filtration, and then we also discussed the principles of centrifugal filtration, and under such conditions we have also taken an example problem. The reference for this lecture is primarily the entire lecture has been prepared from this first reference book, Unit Operations of Chemical Engineering by McCabe, Smith and Harriet. However, there are a kind of other reference books that we have in this course, in which you can find some information about this principles of cake filtration processes. Thank you.